Rational equations. So a rational equation, basically an equation that has a rational expression in it. So remember, those rational expressions have variables and polynomials in fraction, within a fraction, in the numerator or the denominator. So we're going to start looking at equations that have fractions in them, but with polynomials in them. And the methods for solving those equations are the same as for any equation that has fractions in it. So what can we do? Rational equations can be solved by using cross products or finding the LCD of all the fractions and multiplying each side by the LCD. So let's see how this works. Solve each equation and we're going to check the solution. So this equation, 13 over 10 equals 2f plus 2/10 over 7. This is a proportion, basically, two fractions equal to each other. So we can solve this using cross products. So we're going to do 13 times 7 equals 10 times 2f plus 2/10. Don't forget that we really need to put this numerator in parentheses because we need to use distributive property on it. So we end up with 91 equals 20f plus 2. From here, we're just going to solve. So we subtract 2 from each side. We get 89 equals 20f. Divided by 20, we get 4.45 equals f. So if I put this back in here, I'm going to end up with a fraction that is equivalent to my 13 over 10. All right, let's take a look at two more that have a little more going on in them. So I've got n over 3n plus 6 minus n over 5n plus 10 equals 2/5. So we're going to solve each of these equations, but we need to pay attention to extraneous solutions, because notice what we have now is we have a variable in the denominator. And as soon as we have a variable in the denominator, we need to pay attention to using a value for that variable that will make the denominator equal to 0. So let's see what we can do. So the first thing we're going to do is we're going to factor out each of these denominators. So my first one is 3 times n plus 2. My second is 5 times n plus 2. And my last one is 5. So I can use the n plus 2, I can use the 5 and the 3, which gives me an LCD of 15 n plus 2. So I'm going to make each of these denominators equal to my 15n plus 2. So this first fraction I need to multiply by 5, so I get 5n over 15n plus 2. My second fraction I need to multiply by that factor of 3, so I end up with 3n over 15n plus 2. And my 2/5 I need to multiply by 3n plus 2, so my numerator starts to look like 6n plus 2 over 15n. Negative 1 squared is 1. 1 minus 4 gives me negative 3. So negative 1 works just fine in there. So I have one solution of negative 1 and an extraneous solution of negative 2. So two ways of solving equations that have rational expressions in them. They just have fractions. I can use cross products if that's appropriate. And if not, I can find common denominators for each of my fractions and then multiply by that common denominator to get rid of my fractions and end up with just a nice straightforward algebraic equation.